Chapter 7, Similar Polygons. Today we're going to cover Section 7.6, Proportional Lengths. Your class opener. The diagram, not drawn to scale, shows a film being projected on a screen. LF equals 6 centimeters and LS equals 24 meters. The screen image is 2.2 meters tall. How tall is the film image? Your objective. After studying this section, you'll be able to apply the triangle proportionality theorem and its corollary, and state and apply the triangle angle bisector theorem. Theorem 7-3, triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. So I'm really looking at, we have the parallel line in this triangle, that it divides the sides proportionally. So I can set up a proportion, and I almost think of the proportion as being set up right in the problem, where I just imagine if I have a over x equals b over y. Remember, there are several different ways to write proportions. You could possibly write a over b equals x over y. It doesn't make a difference. Our first problem here, find the value of x. And I see that the two sides are parallel, so I tend to again think of the proportion set up exactly as it appears here, where I have x over 3 equals 8 over 5, and then I just cross multiply that. So cross multiplying, I get 5x equals 24. I divide each side by 5, and I know if I divide by 5, it doesn't reduce, so I can just leave x as 24/5. Number 2, set up the triangle proportionality. Now, I could set up the new way I just learned for number 1, or I could just keep this as, I notice that corresponding angles are congruent because of the parallel lines. I have similar triangles where I have the small triangle and the large triangle, so sometimes it's almost easier to do the small triangle and the large triangle. And the values in the small triangle are x, and then I can figure out this value here by taking 15 minus 6, which gives me 9. And if I relate those to the corresponding sides in the large triangle, x corresponds to 20, and the 9 corresponds to 15. I can reduce. 3 goes into 9 3 times. 3 goes into 15 5 times. And remember, we said before, you can even reduce across the bottom if you wanted to. 5 goes into 5 once and into 24 times. And I cross multiply this and get x equals 12. Corollary. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. If I look at a sample problem, we had something similar to this before that said if parallel lines cut a transversal into equal sized pieces, then it would have cut the other transversal into equal sized pieces. Now we're saying this also works, just they're proportional. So I notice the 1.4 and the 1.6 are not the same size, but it's going to be the same proportion as the other side. So I imagine setting up a proportion. If I do so, I can get 1.4 over 1.6 equals 3.5 over x. Normally when I get decimals, I tend to not worry about reducing. So if I cross multiply, I get 1.4x equals, and then I need to figure out what's 1.6 times 3.5. So 1.6 times 3.5 is 5.6. Divide each side by 1.4. So divide by 1.4, and I get an answer of 4. Looking at our next problem. I also see a proportion here, and remember there's several different ways you can write your proportion. I tend to just leave them sort of as I see them, so I'm going to write it as x over 5 equals x plus 3 over 9. And cross multiply. X times 9 is 9x. I'm going to distribute the 5. 5 times x is 5x. 5 times the 3 is 15. Get all your variables to one side. So if I subtract 5x on each side, I get 4x equals 15. Divide by 4, and 15 divided by 4 doesn't reduce. So I'm just going to leave the answer as 15/4. Theorem 7-4, triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite sides into segments proportional to the other two sides. So looking at this, I tend to, again, look at it and see the proportion in here. I'm going to get the proportion A over X equals B over Y. So just looking right at the figure even sort of helps you set it up. And now let's do an actual problem here. So find the value of X. And if I just set my proportion up, and I'm thinking if I'm going to have a 12 over 9 is going to equal an X over a 5. And I notice that I can reduce, 3 goes into 9 3 times, and into 12 4 times. And if I cross multiply, I get 3 times X is 3X, 4 times 5 is 20, divide by 3 and it doesn't reduce, so I'm just going to leave it as 20/3. Setting up number 6. I think of my proportion again. I get 14 over X equals 21 over, and I'm sort of missing how big this side here is. Well, I notice if the whole thing is 25 and the piece on the left is X, then the piece that I'm missing over here is going to be 25 minus X. And now I set up my proportion. 14 over X equals 21 over 25 minus X. And you can cross multiply right now if you want to, or we had talked about how you can reduce in a proportion the two values on the top. So I could reduce by 7 and make this a 2 and a 3. Gets my numbers a little easier to work with. Cross multiplying X times 3 is 3X. Distribute the 2. 2 times 25 is 50. Minus 2 times X is 2X. Add 2X to get all the X's to the same side. Divide by 5. And you get that X is 10. And your closure. Tips I would give a friend to solve this problem are